Hi guys, welcome back. This is day 5. The last thing we're going to do with trigonometry is we are going to use trig values to solve real world problems. So yes, that means word problems, but have no fear. I think you guys will do really well and be successful with these. But yeah, this might be the trickiest section that we've had so far. Okay, so my advice when doing a word problem is read the whole problem. Okay, don't start drawing until you're at the end. Make sure you read it, make sure you understand what it is. Then 2, draw the main idea. Okay, all of these things boil down to a very simple scenario. They're going to give you a lot of information about lengths and heights and other things, but just try and focus in on what the main thing they're trying to show you is. And then 3, look for the right triangle. Okay? All of these pictures, again, are just a real world example of a right triangle. So identify that for me, and then you guys should be good to go. So the first problem says a nursery plants a new tree and attaches a guy wire to help support it while the roots take hold. An 8-foot wire is attached to the tree and to the stake in the ground. From the stake in the ground, the angle of elevation to the connection point with the tree is 42 degrees. Find to the nearest tenth of a foot the height of the connection point on the tree. So again, you might have zoned out on that before I even got to the end of it. But the idea, and you can be as creative or not creative as you want, is that there's a tree and there is a wire attached to it to help support it until it is fully grown. So we read the whole problem. This is the main idea. And now hopefully you're looking at this problem and you can see where the triangle is, okay? So once you can identify where the right triangle is, it's going to make it a lot easier to label these parts because you know that everything is going to be, an angle, a theta that you're looking for, or it's going to be a height or a width. So it says an 8-foot wire is attached to the tree. So you want to look at the picture and you want to find where the wire is. So in the picture that we drew, what line represents the wire, and then label it what it is. It says from the stake in the ground, the angle of elevation is 42 degrees. Okay? Angle of elevation is a word or a phrase that you're going to see and hear often in word problems. The angle of elevation always has to come off the ground. Okay? So depending on what your triangle looks like, angles up here in the sky are never going to be angles of elevation. Angles of elevation always start from the ground up. So, meaning if we look at our picture, there's only one angle of elevation that's made with the ground, and that's right here. So this is my 42 degree angle. It says find to the nearest tenth of a foot the height of the connection point on the tree. So where does this wire meet the tree? This distance x is what we're looking for. Once you've drawn that picture, then you should be good to go because then it's just a basic solve for the missing side or solve for the missing angle problem that you're familiar with. So we've got my hypotenuse. Ooh, this is a little too big. We've got my opposite and the adjacent is down here. So if I circle, I can circle O and H. So I'm going to say sine of 42 is x over 8. And then really easy, all I have to do is multiply by 8 on both sides. And you guys should be using your app for that. 8 times sine of 42. And you should get x equals 5.4. Remember, if your calculator is not in degrees, then you're going to be getting the wrong answers. So go to mode in the top left corner and arrow down and select degree. Number 2 says from the top of a fire tower, a forest ranger sees his partner on the ground at an angle of depression of 40 degrees. If the tower is 45 feet in height, how far is the partner from the base of the tower to the nearest tenth of a foot? So, the main idea of this picture is that there is a guy in a tower and he has a friend on the ground. So look for the obvious right triangle, okay? Where is that triangle? What does it look like? Where are, the dimensions of that triangle? So now once you can envision the triangle, go back and label the parts. So it says, a forest ranger sees his partner on the ground at an angle of depression of 40 degrees. Angle of depression is also another term or phrase that you're going to hear a lot in word problems. And angle of depression is a little bit trickier, but you can pretty much think of the angle of depression as an angle of elevation. The angle of depression comes from straight out down, meaning this angle right here is the angle of depression. And that doesn't help us because that angle is outside of the triangle, and I can only do trig with angles that are inside of the triangle, like here or here. So the good news is, because of what we learned in geometry, we know that parallel lines create an alternate interior angle pair, which means that those two angles are congruent. So if that angle up there is 40 degrees, this angle down here is also 40 degrees, which makes it really easy. If you see an angle of depression, if you just always think of it as an angle of elevation, then it makes the problem a lot easier. So, angle of elevation, the tower is 45 feet in height. How far is the partner from the base of the tower? So you're looking at two new distances. Which one is x? Is this distance x or is this distance x? And it comes down to where is the base of the tower. Both of those are distances from the guy on the ground to something, but which line represents the distance from him to the base of the tower? Hopefully, you identified this section right here as the base of the tower, is the bottom, the part of the tower that's on the ground. So, I circle, or I have to label my sides first, sorry. So I've got opposite, hypotenuse, and adjacent, and now I circle. So O and A means I'm going to be using tangent. Tangent of 40 is opposite over adjacent, and this requires the switch. So I know we haven't done the switch in a day, 2 days. I have no idea how the schedule for this works, how often you guys see these videos, but that is the switch that we learned from day 2. And so you type that in your calculator, 45 divided by tangent of 40, and x equals 53.6. And so we keep going. We've got 3 more examples. If you want to try any of these on your own, you're welcome to pause and attempt it and look back and check it later. Otherwise, I'll do them all now. But yeah, use the fast forward, rewind, all that good stuff to make the most out of these videos. And again, you're going to contact me if you have any questions, comments, concerns. If you watch these videos for another teacher, make sure you're contacting them. You're always welcome to contact me, but contact your teachers too. All right, so I will continue on. So it says, find the shadow cast by a 10-foot lamppost with the angle of elevation being 58 degrees. Find the length to the nearest tenth of a foot. So, don't make fun of my lamp. I don't know how to draw a lamp. Wow, I think that's the worst lamp that I've ever drawn. But you get the idea. That's the lamp and this is the shadow. So look for the obvious right triangle. And it says that the lamp is 10 feet tall. And it says the angle of elevation. Remember, angle of elevation is always off the ground. So this is 58 degrees. So label your sides. This is my hypotenuse, my opposite, my adjacent. Circle. And then it says find to the nearest, or find the shadow cast. So which line, A or H, is going to be the variable X that we're looking for? Which one of those lines represent the lamp's shadow? Okay, that's what you want to be asking yourself right now. Hopefully you said this one right here. So we have tangent of 58 equals opposite over adjacent. So again, you want to do your switch. And you type that in on your calculator. 10 divided by tangent of 58. And you should get that the shadow is 6.2 feet long. The next example is a really common example that you're going to see all the time. It is a ladder leaning against a brick wall. This is like the most traditional trigonometry word problem that you're going to see in these examples in the ACT, other math trigonometry classes that you take. It says a ladder leans against a brick wall. The foot of the ladder is 6 feet from the wall. The ladder reaches a height of 15 feet on the wall. Find to the nearest degree the angle that the ladder makes with the wall. So this is an example of what we have not done yet. We have not found the angle, but it says to find it to the nearest degree. So we know how to do that. We learned that last lesson. So we are going to draw a ladder leaning against a brick wall. So this is my building, and this is my ladder leaning against it. So it says the foot of the ladder is 6 feet from the wall. So you need to figure out what's that distance. What does the foot of the ladder mean? Where is the foot of the ladder? Does the foot of the ladder mean the whole ladder? Does it mean the top of the ladder? Does it mean the bottom of the ladder? Foot of the ladder means the bottom of the ladder. So the distance from the bottom of the ladder to the wall is 6 feet. It says the ladder reaches a height of 15 on the wall. So we don't know anything about the length of the ladder, but we know that this height that it touches the wall is 15 feet. Hopefully you can see the right angle is here. It says find the nearest degree the angle the ladder makes with the wall. Think about what that means. There's two angles that could possibly be theta. This could be theta or this could be theta. Which one of those is an angle formed by the ladder and the wall? One of those angles is a ladder and the ground. One of those angles is a ladder and the wall. Which one of those angles is ladder and the wall? And how do you get that? So, ladder and the wall. It's really important where you label that theta because that theta controls which side is opposite and which side is adjacent. And we want to label those correctly. And we've got tangent of theta equals opposite over hypotenuse. So again, this is when we have to inverse tangent both sides to undo it. You type that in on your calculator using the second button, second tangent. And you should get 21.8 degrees. And then the last one, a plane climbs at 5 degrees and flies 20 miles through the air. What is the altitude of the plane to the nearest foot? So this is a small word problem to give you all the information right away, but there's a lot of key points in here that we need to identify. So it says a plane climbs at 5 degrees. So I'm going to say that this was my plane taking off the runway. I don't need to know how bad you think that plane is, okay? But that is it, taking off the ground and climbing at 5 degrees. It says that it flies 20 miles through the air as it climbs. So from the moment it's left the ground to where it is now, it's traveled 20 miles. What is the altitude of the plane to the nearest foot? Altitude always means straight down to a 90-degree angle, okay? We learned about altitudes in geometry last year. Hopefully you guys remember those medians and altitudes. Altitudes always end in a right angle. So that means from where the plane is, straight down to a right angle it wants to know this height right here. How high is the plane from where it is straight to the ground to a 90-degree angle? So from there, I label my sides. I've got my hypotenuse, my opposite and adjacent. I circle, and I get sine, because the O and H means I have to use sine, of 5 degrees equals opposite over hypotenuse, which means we end on an easy one, because all we got to do is multiply 20 times sine of 5. X equals 1.7, 1.7 miles in the air. So the plane is only a mile off the ground after it's gone 20 miles from the runway. So that's our word problems. That is the end of our lesson for today. Remember, reach out if you've got any questions, comments, concerns about anything. If you need more practice on anything, if you want me to send you additional things, I'd be happy to. It's been a long time since I've seen you guys, and I love you very much, and hope you guys are all doing okay. I love you so much. Be good.